Okay, so integrating now cos x and sin x, all right? Now, you've got to realize that they are opposites to what you've learnt in differentiation. Let's just remind you of differentiation. You know when you've got y equals cos x, okay? When you do dy dx, you get minus sin x, don't you? Okay, and then when you've got y equals sin x, you get dy dx to be cos x, okay? Now, the kind of opposite process occurs when you integrate. So when you integrate cos x dx, you don't get minus sin x, you get just sin x, okay, or plus sin x, plus c, of course. But then when you integrate sin x, you get minus cos x plus c. Okay, so the opposite sort of process sort of occurs there. And it does make sense, because if you differentiated this back, differentiated sin x, you'd get cos x. If you differentiated cos x, you get minus sin x. So if you wanted sin x, you'd need to differentiate minus cos x to get the sin x. So it kind of makes sense there, but it's the opposite process. The other thing as well, when it comes to differentiation, if you've got y equals, say for instance, sine 2x, okay, when you do dy dx, okay, of course, sine becomes cos, so that'll be cos 2x, okay, because sine x becomes cos x, so sine 2x will become cos 2x, but of course this is a function of a function, isn't it? This is like sine of 2x, so sine becomes cos, but then you've got to times them by the derivative in here, okay, so you differentiate the outside to get cos 2x, and you've got to times by the derivative in there, which is 2, so you end up having 2 cos 2x, okay? Now, a different sort of approach occurs when it comes to integration, because when you integrate, say for instance, you want to integrate cos 2x, right, dx, if you're going to integrate that, then of course cos, when you integrate it, you get sine, okay, so that would be sine 2x, but this time, instead of timesing by the derivative in here, you've got to divide by the derivative there, okay? It's the opposite process, right? That's kind of how it works. That's a constant, of course, but it's the opposite process when you integrate. When you differentiate, something like this, you differentiate the sine to become cos of 2x, and you times by the derivative in there, which is 2. But when you integrate, you do what you normally do, cos becomes sine of 2x, but then instead of times and you divide, you're doing the opposite. So we can apply that now to these sort of questions. Okay, so we've got this here. Part A, you've got the integral of cos 5x dx will equal to, that would be sine, won't it? I've got to think myself now, because it stays as a plus, the sine 5x, okay, but you divide then by the derivative, which is 5, plus then c. Okay, so when I do b then, when I integrate sine 5x, now when you integrate sine, it becomes minus cos of 5x, divide then by the derivative there, which is 5, and you get that. Okay, c then, integrate 5 cos 10x, okay, so cos now becomes sine, doesn't it? Now there's a 5 there, but that's okay, just leave that there. Is a constant multiplied by it. So it'll be sine 10x, but divide then by the derivative there, which is 10 plus c. That would simplify, wouldn't it? You get a half, wouldn't you? Okay, so you get a half sine 10x plus c. Okay, so then d then, I got my d written up here, I'll write it down here. d is minus the integral of minus 3 sine 3x dx. Okay, so I got to remember now what the sine becomes. Sine becomes minus cos, doesn't it? Right, you've got to remember this. Sine becomes minus cos. It's always the opposite of differentiation. Think about when you differentiate. When you differentiate cos, you get minus sine. So here, when we talk about integrating, you're going to get the minus cos coming out, and it's the opposite. So here you have the minus cos, but there's already a minus there, so that will turn to a plus overall. Cos 3x over then 3 plus c. 3's cancel and you've got your answer. E, now with e, okay, now cos, if you're struggling to remember whether it's a plus or minus, I always just think back to integration, and I think when I differentiate cos, so I think back to differentiation, when I differentiate cos I get minus sine, so now when I integrate cos, it's not going to be minus sine, it's going to be plus sine, x over 3. Now we differentiate in there, then is a third, so you divide them by a third plus c and then you can take the 3 up, can't you? You get 3 sine x over 3, and so on. F then is similar, of course. Okay, so you get, with f, you get minus, of course, this time 2 cos x over 6 over, then differentiate this, you get 1/6 here, isn't it, plus c, and then you can simplify that. With g, when you integrate sine, you get cos, or minus cos, sorry, 5x plus 1, and then divide by the derivative in there, which is 5, yeah? If we differentiate that there, you get 5 plus c, okay? So I leave h because I look at something similar to that in the next video.